Hi, my name is Pat Osborne, and today we're going to do a chlorine dioxide demand study in order to determine the minimum amount of chlorine dioxide we need in order to completely treat a water sample. We're going to do this until we obtain a residual level of chlorine dioxide to ensure we've completely killed any contaminating bacteria in the sample. We're going to do this using an ORP method. ORP stands for oxidation reduction potential, and it's the relative measure of any oxidative or reductive species in our water. Now we're going to perform our chlorine dioxide demand study. In order to do this, I've generated a stock solution of chlorine dioxide using the same chemical composition as the DuPont chlorine dioxide generator. I've analyzed the stock solution for its exact concentration and then used that concentration to calculate small incremental doses that we'll be using to run our demand study. Our small incremental dose will be 10 ppm, and after I apply it, we'll observe the change in ORP. I'm applying our chlorine dioxide solution subsurface into the sample to ensure there's no off-gassing. And with that, there's an immediate response in ORP increasing. Following that large increase, now the ORP level is falling off. So this is an indication that the demand of this water has not been met and additional chlorine dioxide is needed. So with that, we'll add another 10 ppm dose to the sample. Again, we have an increase in ORP. And what we're looking for here is for that ORP level to stabilize and really level out. But as you can see here, it continues to fall off. So that indicates our demand hasn't been met, and we'll add another 10 ppm dose. So while we're doing this, we're keeping track of the total chlorine dioxide dose that we're treating with. So this would be a total dose of 30 ppm. Now it looks like the ORP level has leveled out around 80 millivolts. So this is a good indication that residual chlorine dioxide is likely present. But in order to confirm this, we're going to perform a residual analysis test to determine the residual, and then from there we can calculate the demand of this water. Now that we've done our demand study and we've reached an ORP level that indicates that a residual might be present, it's important to then confirm that we do have a chlorine dioxide residual in this sample. So how we're going to do that is through our ionometric titration using the Hach digital titrator. I pulled 50 mils of our sample and put it into the flask here. First, I'm going to add our phosphate buffer. This ensures that our sample is kept at pH 7 and we're only measuring chlorine dioxide in our analysis. Then going to add 1 powder pillow of potassium iodide. The potassium iodide is going to react with the chlorine dioxide in the solution. The chlorine dioxide is going to oxidize the iodide and form a yellow complex, which is directly proportional to the amount of chlorine dioxide in our sample. Then going to add 1 dropper full of our starch indicator solution. The starch indicator solution reacts with the oxidized iodide and forms a purple complex. And the color change is proof that we have residual level of chlorine dioxide in the sample. Now that we've determined there is residual chlorine dioxide, it's important to measure that residual to see if it's within the parameters that we desire. So to do that, we're going to use a Hach digital titrator using a sodium thiosulfate cartridge. With the titrator zeroed, we can begin titrating in, and our goal is to titrate until we reach an endpoint where the colors change from that dark purple to our original color. Once we reach that endpoint, take note of the titrator reading, and we can then calculate how much residual we have in our sample. So from our titration, we've calculated out that our residual chlorine dioxide level is 3 ppm. We subtract this 3 ppm from our total chlorine dioxide dose of 30 ppm to say that the demand of this water is 27 ppm. This is important because we've confirmed that we have residual chlorine dioxide and it's at a safe level to prevent any off-gassing or exposure when applying it in the field.